Hey guys, welcome back. In this video, I want to provide you the proof for the product rule of differentiation. Even though we didn't derive the proof, we have already been using for many years. For the product rule of differentiation, if we have the function which can be expressed in the product of the two subfunctions, we can directly take the derivative of the function in the product form. If we have y is the product of two functions, f of x times g of x, okay? Then we can take the derivative of the function, both the function in the product form with respect to x as dy upon dx equals to first function times the derivative of the second function plus second function times the derivative of the first function, okay? Or if we express in simple way that if f of x is equals to u and g of x equals to v, then differentiation of u times v upon dx is just u times derivative of v with respect to x plus v times derivative of u with respect to x. So this is the product rule of differentiation. Now let us prove this rule from the first principle, which is the limit definition of derivatives. Okay, now we can see this as dy upon dx is just d upon f of x times g of x with respect to x, can be written as limit h approaches to 0 f of x plus h times g of x plus h minus fx times g of x divided by h, okay? So this is the limit definition. Okay. Now, like the earlier proof of the chain rule, we have to modify this expression to apply the limit. So now what can we do is, see here, we can modify this expression by adding the terms f of x plus h times g of x and subtracting the term by f of x plus h times g of x. Because if you notice that this sum is equals to 0. So if you even add 0 here, the meaning of the whole equation will not change. But by adding these, we can modify in such a clever way to apply the limit and evaluate the limit so that we can reduce this form to the limit definition. And for the single function of x, we have to know that if it is f of x, okay, then f prime of x can be written as limit h tends to 0 fx plus h minus f of x upon h. So this is the limit definition for the single function. But here it is the function in the product form. So now by making this modification, we can write as limit h approaches to 0 fx plus h gx plus h minus fx plus h g of x plus fx plus h g of x minus fx gx all divided by h. Now what we can do is we can collect the like terms together, okay? So for this, what can we do is we can collect like this: limit h approaches to 0 1 over h, this h, times here we can take this fx plus h as common term. Now what is left now? G x plus h minus g of x plus here g of x is a common term, g of x. Now what is left? fx plus h minus f of x, right? Okay, now we can distribute this limit to both the terms. Now what can we do is we can distribute this 1 over h to both the terms as well as the limit. Okay, by doing this, what we will get is we will get limit of h approaches to 0 fx plus h times gx plus h minus g of x, right, divided by h plus limit h approaches to 0 g of x f of x plus h minus f of x divided by h. Okay, now if you observe these functions very carefully, we can distribute this limit to this one as well as this, right? Because this function is also dependable to the limit because it has the h term. But as we know that this function, when h approaches to 0, this f of h approaches to f of x. So by applying this limit, now we will get f of x, right, times. Now if you see this, we have to apply a limit here also, right? H approaches to 0. If you apply this, this is just the expression for the limit definition of the derivative, and this whole expression is just the g prime of x, derivative of x. So we can write g prime of x plus, here this gx is independent of this limit, so it is gx times, and this limit should be distributed to this also, to this term. So by distributing this limit, this term is exactly this. So this is just f prime of x. By this, we have successfully derived the expression for the product rule, which is d of f of x times g of x upon dx is the sum of first function times the derivative of the second function and the second function times the derivative of the first function. So this is the product rule, okay, that we have derived right now. And already said that this term is added just to modify in this form so that we can evaluate the limit. Okay, I hope you all have enjoyed this proof, and I'll see you in next video. Thank you.